In this video, we're going to discuss the concept of practical significance. So definition. Practical significance refers to the idea that while small differences between the statistic and parameter stated in the null hypothesis are statistically significant, the difference may not be large enough to cause concern or be considered important. So the point here is that just because something is statistically significant, that doesn't necessarily mean that there is a need for worry or concern from a practical standpoint. So the idea here is don't lose common sense. Just because something's statistically significant, that doesn't necessarily mean that it is a big deal from a practical standpoint. That's the idea. Now, we're worried about things being statistically significant, and so we're concerned about that. But again, don't lose common sense. Just because something's statistically significant, that doesn't necessarily mean it's going to cause concern or really be that big of a deal. So let's take a look at an example of this. So example, according to the American Community Survey, the mean travel time to work in Collin County, Texas in the year 2013 was 27.5 minutes. The Department of Transportation reprogrammed all the traffic lights in Collin County in an attempt to reduce travel time. To determine if there is evidence that travel time has decreased as a result of the reprogramming, the Department of Transportation obtains a random sample of 2,500 commuters, records their travel time to work, and finds a sample mean of 27.2 minutes with a standard deviation of 8.5 minutes. Does this result suggest that travel time has decreased at the alpha equals 0.05 level of significance? So we're going to conduct a hypothesis test to determine if the travel time to work in Collin County, Texas has decreased as a result of the Department of Transportation reprogramming all the stoplights. So we're going to have a null hypothesis and we're going to have an alternative hypothesis. This is about the mean travel time, so our null and alternative hypothesis are going to involve the mean mu. And so what should mu equal? Well, in 2013, historically, right, the commute time has been 27.5 minutes. So our null hypothesis is that mu equals 27.5 minutes. And the Department of Transportation is hoping that the time has now decreased. So we want the alternative hypothesis to be less than 27.5 minutes. So this is going to be a left-tailed test. So again, we're comparing, is the time still 27.5 minutes after they reprogrammed the lights, or is it now less than 27.5 minutes after they reprogrammed the lights? And we were told to use alpha equals 0.05 level of significance. So we could do this problem using the classical approach or the p-value approach. We could do this by hand, we could use the TI calculator, or we could use StatCrunch to do the calculations. I think I'm going to just use the p-value approach, and I'm going to let my TI calculator do the calculations. So in this case, I'm just going to worry about the p-value, and I'm going to let my calculator do the work. So I'm going to pull in my calculator. I'm going to go to Stat, Tests, and T-Test. In this case, I have statistics. I have summary information here. So the mean in my null hypothesis is 27.5 minutes. In my data, the value of X bar was given to be 27.2 minutes, and the standard deviation was 8.5 minutes, and our sample size was 2,500. Our alternative hypothesis is less than, and so if I compute, the calculator returns both the test statistic, which is negative 1.7647 or 765, and I get a p-value of 0.0389 if I round to 4 places. So my p-value is 0.0389. Well, that is less than 0.05, our level of significance. So that tells me to reject the null hypothesis. So we're going to reject that the mean is equal to 27.5 minutes, and we're going to conclude that now the time is less than 27.5 minutes. So does this result suggest that the travel time has decreased? The answer to that is yes. This suggests that the travel time has decreased. So there is statistical significance. Because the Department of Transportation reprogrammed the lights, it does appear, based on this result, that the travel time has decreased. So there's statistical significance. So what does this have to do with the concept of practical significance? Well, look at what our original average time was. The original average time was 27.5 minutes. Now, it appears that maybe it's 27.2 minutes because that was the result whenever we took our sample of 2,500 commuters. So if we compare the difference in that, 27.5 minutes minus 27.2 minutes, that is a difference of 0.3 minutes. And 0.3 minutes, if we take that times the fact that there's 60 seconds in a minute, so 0.3 times the fact that there's 60 seconds in a minute, that is 18 seconds. So it appears, based on our results from this sample, that the travel time may have decreased by 18 seconds. So the question then is, do you think that any traveler in Collin County, Texas noticed that the travel time to get to work decreased? Do you think they slept in late because of those 18 seconds? Well, the answer to that is obviously no. So there was a significant difference statistically, but from a practical standpoint, 18 seconds was probably not even noticed by the travelers in Collin County, Texas. So even though there was statistical significance, from a practical standpoint, it really wasn't a big deal. So if the Department of Transportation spent a huge amount of time and a huge expense reprogramming all of the lights, then that time and expense was probably wasted because there wasn't much practical effect. One last thought on this idea. Notice that we had a really large sample size. We had a sample size of 2,500 in that example. Well, large sample sizes can lead to results that are statistically significant, while the difference between the statistic and parameter in the null hypothesis is not enough to be considered practically significant. So part of the issue in that Collin County transportation problem is the size of that sample. We have such a big sample size that can make things statistically significant while there may not be much of a practical significance. So just keep that in mind in real practice, that just because something is statistically significant, that doesn't guarantee that the consequence is really meaningful. Just keep that in mind. Not to undermine what we have learned, because obviously statistics are useful in determining if there's any kind of a significant change in a parameter. But again, just don't lose the common sense and overthink what statistical significance really means from a practical standpoint.